Can you please okay, okay, yeah, the recording is started. Okay, once again, guys, I would like to welcome everyone um into today's meeting, and hopefully everyone had an amazing day. Can I just update this person that it has started to record? Yes. So hopefully everyone had an amazing day. Can you guys, before we go any further, please confirm for me if you are able to see my screen, and then we shall start with our meeting. Can anyone just confirm for me if they are able to see my screen? You can send the message on WhatsApp or just unmute yourself here, confirm, and then we shall begin. I just want to make sure of that if you guys are able to see what I'm doing here, because it's gonna be pointless for me to do a meeting while you guys are not able to see what we are doing. Okay. Seems as if no one is responding, so let's just get into it. Let's see. I want to get new. Okay. I want to get that question paper we were doing yesterday. I think it's 2018. 2018. That's it. Here, the question paper. Oh, I probably need to just screenshot it first. Okay, did I? Okay. Image. Hopefully it's still here. It's still here. This one is, let's see this one is for today. Let me quickly look for that one. Think we did this question 5. Let's see question 6. Yes, there is question 6 done. Okay, now we can move this. Now we can move this to up here. Okay, and then let's take this one here, drop it. Okay. Drop it. Yeah, that's more like it. That's more like it. So, guys, we'll be continuing with functions as we did yesterday. Um, yeah, maybe just to recap, what we talked about yesterday. We talked about the 4 basic functions that we deal with in grade 10, of which was the linear function, the parabolic function, of which is sometimes called the quadratic function, and thirdly, the hyperbolic function, function. Uh, fourthly, was the exponential function. And remember that we said that functions are basically a way of representing relationship. For instance, you know, if you have already gotten into what you call this thing, financial mathematics, you know, we may not have a deep understanding of it as of yet, but um, with the exponential function, there's some with sorry the financial maths. There's something called a compound interest. So a compound interest grows exponentially because it is calculated based or on there's something called the present value. There you will take your initial value at the interest, say maybe of 5%, and then have that total amount. And then when you calculate the interest again, it will be calculated based on the new value. Let's say maybe you had 10,000, and then we invested it with a certain bank, and then at the interest rates of 10%, that means you are getting 10% maybe monthly. That means you are getting 1,000 rand per month on your investment. So or at least on the first month. So what will happen is that you will get 10,000 rand. That will be your new value for the oncoming month. So the oncoming month, your interest won't be calculated based on the 10,000 rand of which was the initial value, but now will be calculated on the 11,000 rand. 11,000 rand of which was the new value right now. So you'll be getting 1,100 1,100 interest, you know, as that new person. And then it just keeps on going like this. So right now, as I'm mentioning this example, I'm trying to help you get your head around this. You know that functions are basically ways of representing relationships. So that type of an interest will be an exponential function. So we can represent that type of a compounding interest as an exponential function. You know, so a relationship between your it could be between your interest and then your what's you call this thing, yes, and months, or yes, it could be a relationship between time and the interest that you are getting. So the function that we're gonna have with that relationship, it's gonna be an exponential function because a compound interest increases exponentially, you know. And then you also have a simple interest of which can also be represented by functions. I think the type of function that we'll get there is just gonna be a linear function because the interest doesn't change. It is always calculated based on the initial value that you invested. So if you get a 10% interest on 10,000 rand with simple interest, so what will happen there is that um, each and every month, let's say you initially invested 10,000 rand, and the 10% of 10,000 rand is what is 1,000 rand. Each and every month, you will be getting just the interest of 10,000 rand, and that will be a linear function. Your money will not grow exponentially, but it will grow linearly. You know, it will grow linearly. So, by mentioning this, I'm just trying to help you guys get your head around this, so that once you have real life examples of where these things come into play, it becomes easier to even understand them mathematically. You know, because now you know where we can use these things. You know, so that was just an example as I wanted to mention. Another thing that we mentioned yesterday is that functions are continuous. You know, functions functions are continuous. Eh, hopefully my spelling is not wrong. Continuous, not wrong here. Yes, but function are continuous. You know, so hence why you'll see when we represent function, we always put those small errors, whether it be a linear function like this, or whether it be a what we call this thing, a parabolic function like this. they are always linearly, so they are always, sorry, continuous. Functions are continuous. We also touched on the domain and range, on the domain and range, domain of different functions, you know, domain and range. And remember, that's I told you, that's a simple way to remind yourself of this. Just focus on that range, and that small g here, which looks like y. you know this g that I've just written here, which looks like y. That will tell you that with range we're dealing with what, with the y values, so when we're talking about range, it's just the y values where our function exists, so even when we look at it graphically, let's just say, take an example with these functions that we have just drawn here, we'll just assume that this parabolic function, of course, starts here from 0. So if we were to write a range for this parabolic parabolic function, and we're only looking at the y values, that means we're looking at this line here. We're only looking at the y values. Our function doesn't exist below that 0 line, below this x x-axis. Our parabolic function, we are focusing on the parabolic function, sorry. It doesn't exist below that 0 line. So which means if we were to write the range for that function, it's gonna be what? Y is an element of what? We always starting with the small one, element of 0. Okay, we're putting in a number here, so we can use a square bracket, even though I don't think they will penalize you for that, but just to be safe, a square brackets, and then it goes continuously so high, into what? Into the positive infinity, so because we don't know where this function ends, so it ends at such a big value because functions are continuous. Just because we carry it here on the paper, it doesn't mean that it ends there, so it's continuous into the positive infinity. That will be the range for which this function exists. And then for domain, when we talk about the domain, remember, it's the x values, the opposite of the range. It's the x values for which our function exists. X values for which our function exists. So if we were to just also do the domain for that parabolic function again, we will say x is the element of, I guess you can see, because one thing you should remember is that functions are continuous. As much as it is going in this direction, this function, it is also going in that direction, even though it's going faster in the vertical direction, but it's also getting bigger and bigger. So it's also expanding to the left. It's also expanding to the left and right, while it is also going up, So if we were to write the range for this function, we would say what? It starts from whatever value that we don't know, that very, 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 very small value, of which we would just say it's a negative infinity up to there, and it also goes in the positive direction into the positive infinity. And then another thing that we introduced yesterday is the general forms for these functions that we are talking about, So I'm just recapping on what we did yesterday, because we're gonna use some of these things to answer the questions that we have today. So for straight line function, the general form or the equation, for simplicity, the equation is what? It's y is equal to mx plus c, where our m is a what? Is our trident for a straight line function. M is the trident. Okay. M is the trident, and we say we said in order to find m, we can just say if we have two coordinates, y2, take any two coordinates on the on the on your function, and then just do this ratio where you subtract the y values over the difference of the x values. This is how we find the domain, sorry, the gradient of a straight line function. And then with that c, we said it's a what? C C C is our y-intercept. Y-intercept. And remember that we find the y-intercept where x is equal to 0. Our function will cut the y-axis where x is equal to 0. Where x is equal to 0. Oh, okay, maybe let me move and just put that where there. Oh, what am I doing? Okay, I just want to quickly put that where x is equal to 0, and then that's where we find our y-intercepts. And then for the parabola, just a quick recap. For a parabola, our general formula is equal to y is equal to ax squared plus c. And then once again, our c there will be our what? Will be our y-intercept, because if again we insert 0 here in that x, it will cancel out this term. If we were to say x is equal to 0, it will cancel out this term. So c will end up being our y-intercept again. C is our y-intercept. Is our y-intercept. Yes. And also generally it becomes our turning point also. Our turning point. It's also our turning point. It's also our turning point if we have the standard parabola like this, unless of course it is shifted. If it's shifted, then it becomes a different thing, but generally it is our turning point. And then the sign of a there on a parabolic function, sign of a will give us the shape of the function. If it's a positive a, we're gonna have a parabolic function like this, that smiley face. If it's a negative a, we have this sad function facing down. Why these things? Okay, let's just leave it facing down. And then let's move to hyperbola or hyperbolic function. The general form is what? It's y is equal to ax plus q. And remember that I told you that, okay, for these two, for the first two functions, we have something in common, of which is the intercepts, and for these two functions right now, we also have something in common, of which we call the asymptote. Is the value where our function doesn't exist, it doesn't touch that function, and then for the hyperbolic function, q is our asymptote, equal to okay, asymptote is our asymptote. Yes, q is our asymptote. And then also And lastly, we touched on exponential. Okay, apparently I can't write here. I'll just write here and move it there. Exponential function is our exponential function. That's the last one that we touched on. And then the general form is what? Y is equal to AB to the power x plus q. Q is our asymptote again. Q is the asymptote. Asymptote. Okay, so that is that. That is that. I think we can get into questions. If something comes up that I haven't what you call this thing touched on as a revision, we will just revise it as it goes. Or maybe just before we go, let me just write the general shapes for these functions. I've drawn one for already drawn one for for the parabola, and then for the what we call this thing for the straight line. So generally, a hyperbolic function will look something like this. That's the general form of an hyperbolic function, and then it will have an asymptote maybe here or maybe directly on the x-axis. This is the general form of a hyperbolic function. Hyperbola, and then the general form of an exponential function, it looks something like this general form, and then maybe we will have an asymptote here, a level that the function doesn't touch. It may approach, but it doesn't touch. You will see once you start doing calculus, there will be limits, so you will be calculating these things, but in another form of mathematics, you would get to that. You'll get to that. Okay, let's get to the question. Because at the end of the day, we can learn as much as we learn and understand the concepts. It's very important to understand the concepts, but with mathematics, the most important thing is to actually practice these things, as much as we can. As much as you can, just make sure that you practice. Okay, let's get into question 6 now. Let's get into question 6. So it says the equation of the function g at x. Equation of the function g at x. So I also like to just write the important things as I read the statement, because it simply helps you understand better, and I'll also encourage you maybe just highlight the important things about the function while you are writing it, to better understand the statement and understand what you are given, and by just looking at this statement here, you can already tell that this is what form of a function is an hyperbola, because we have that x in the denominator and that q for the asymptote. So this um is an hyperbola. Just just to mention that, and also once we understand that this is an hyperbola, we know we see q is a what? Is an asymptote. Q is an asymptote. Just remind yourself of these things. all the negative y values, but not for 1. Once we reach that 1, our function will jump, will jump and then exist again for what? For the positive y values. So you can already tell just by looking at the range, you already have your answer for q, because q is the asymptote. It's the level that our function doesn't touch. Q is equal to 1. That is our asymptote. And our, let me just put in brackets, horizontal asymptote, where y is equal to 1. That is our horizontal asymptote. Okay, let's get to the question. Determine the equation of g. Okay, determine the equation of g. 6.1, and it's what? It's 3 marks. 6.1. Let's bring back the general term that they gave us. Grx is equal to ax plus q. We already have q. We've already determined q from our range there, which is the asymptote. Therefore, we put back grx. It's a over x plus, let's put 1. Okay, but back to the statement, we're also given a coordinate there. A coordinate, this coordinate 3 and 2. We are told that our function also passes through that coordinates of 3 and 2. So we can see, okay, from having these 3 unknowns, if we just substitute these 2, we can be left with now only a as an unknown. Then we can solve for a. We already solved for q. So let's come here and say what? 2 is equal to 2 for y, a over 3 plus 1. Therefore, we take 1 into this side. It's gonna be minus 1. So 2 minus 1, it will be equal to 1. Therefore, a over 3 is equal to 1. We have just transposed this 1 into this other side to end up with 1, and then it's gonna be 3 times 1. Therefore a is equal to 3. A is equal to 3 because we take this 3 on the denominator and multiply the 1 there. Okay, then we can write our equation for g right now. Maybe use a different color. G at x is equal to, our a is 3 over x plus 1. Then we are done with the equation of g. That's the equation of g. And then equation of h, the axis of symmetry of g, which has a positive gradient. So right now, from the range and the asymptotes and just the general formula for the type of function, you can already tell that we are dealing with what? We are dealing with an hyperbolic function. So today we're also gonna learn something new. We're dealing with a hyperbolic function, of which our asymptote is and the 2 marks. Our asymptote is 1 here. Q is equal to 1. And you don't have to do this in the test. It's just for demonstration. It's just for demonstration for the something that they ask for in question 2. So our function will look something like this. This is our asymptote, and then maybe something like this. This will be our function. And then they're asking for the positive gradient for the axis of symmetry of g, the axis of symmetry. So our axis of symmetry, they pass here where we have the asymptote. Our axis pass there, our axis of symmetry, where we have the asymptote, and it's just the reflection of the function if we were to flip the function. And another thing that I should mention is that we have two axes of symmetry. We have this one, of which is the positive, or of which is the one that has a positive trident, you know. So this is the axis of symmetry, the first one. And the trident, oh, another thing that I should mention, the trident for the axis of symmetry is always equal to 1. M is equal to 1 for the positive axis of symmetry. And then we have another one which will be perpendicular. Maybe let me use a different color. Perpendicular to the other. So our graph can be reflected about this axis of symmetry here, this axis of symmetry here, or it can be reflected about this axis of symmetry, you know. But for this one, it has a positive trident of which is -1. This one, it has a negative trident of which is m is equal to -1. So we are looking for the equation of h, the axis of symmetry of G, which has a positive trident. So we're looking for this equation. This is the equation we are looking for. And this equation is a what? Is a straight line function. So the form for this equation is y is equal to mx plus c. Y is equal to mx plus c. We already have the trident there, of which is equal to 1. Y. Sometimes this pen doesn't write properly. Is 1 into x plus c But we also have another thing there, the what we call this thing, the y-intercept here, you know, because our axis of symmetry, they pass through that line of asymptotes, and we already know that the value here of this line of asymptotes, y is equal to 1, is this asymptote. So we already have it here, this one, y is equal to 1 there. And x is equal to what? Is equal to 0, since it's there, it's the intercept. So we can just sub in those values and calculate the value of c, where y is equal to 1. Our x of symmetry passed there is equal to 1 into 0 plus c. Therefore, our c is equal to 1 also. Is equal to 1. Our c is equal to 1, and therefore our axis of symmetry, or our h, the equation that we're looking for, is gonna be x plus 1 for a positive trident. This is your final answer, and there is your 2 marks. So when you get to the exam and you understand that, okay, the positive trident is equal to 1, there is no need to write this. You can say, okay, m is equal to 1, and then you take that point that we already have there, where our the point of the asymptote, because our axis of symmetry, they pass through the asymptotes. Maybe I should write that somewhere, that the axis of symmetry, they pass through the asymptote, you know. So if you have a trident and a coordinates, you can calculate an equation, you know. So axis of symmetry passes through the asymptote. Okay, now we have the equation of h. Okay, let's go to 6.2. Sketch the drafts of G and H on the same axis. Clearly show all the asymptotes and the intercepts with the axes. Okay, unfortunately, we've already drawn these drafts, but we just sketch them again. We just sketch them again. Um, but it's gonna be the same as this one. But let's just do it again. Let's just do it again for the sake of answering every question step by step. Step by step. So this is our axis, x and y. Oh, another thing that's I should mention that is very important. Always label your axis x and y. That's very important. I know sometimes I do forget myself to mention this to label these things, but it's very 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 important. Always remember, if you are asked to draw these things, to draw these functions or these graphs, always label your what you call this thing, your x and y axis. Your x and y axis is very important. Sometimes they do allocate marks on that, so it's very important. And then this is the asymptotes for the for the for this equation of G, of which is equal to 1. Is equal to 1. We can just put here y is equal to 1. Maybe a different color. Maybe this one. Okay. It's just y is equal to 1. Okay. Now we can. That's the asymptote. Okay. I want to draw this thing nicely. So maybe let me start with this one. It's gonna be like this. Yes. Mm. Well, this thing. Yeah. Then it's gonna be something like this, and then it's continuous. It's continuous in this direction. Continuous in this direction. Yes, that is that. That is that. Okay, and then we asked to draw the graph of H also. This one is for G. This one is for G. And then the one for H, just use black. This is the graph of H. Of H. Another thing that they can ask you, I know that I see you could see they didn't ask for this, but another thing that they can ask you is that maybe write the terms maybe of X whereby G at X is equal to H of X. I know questions like this they do come sometimes. Graphically, they would be asking for these values here. For these values here. That is where these graphs are equal, those coordinates. So what you do in such a case, hopefully it's not tedious to answer this one. But okay, it's 3 over x plus 1. This is the formula. 3 over x, we're just going to take this part, 3 over x plus 1. Just going to find the x values where these graphs are equal. Plus 1 is equal to h at x. It's x plus 1. X plus 1. Okay, and then let's solve for x now. Let's solve for x. If we transpose this one here into that, if we transpose that into that, it's gonna cancel since it's the same, then we'll be left with 3x. Okay, maybe let me just write it out so that you guys can see what I'm doing. -1, this will become 0. then we'll be left with 3x is equal to x, just to make sure that not there is no one that is confused. Then it's gonna be x times x. That means it's 3 is equal to x squared, and then we put a square root on both sides, and x will be the root of 3. Would be the root of 3, of which I think it's 1 point something. 1 point something square root of 3. It's 1.73. 1.73. So it's gonna be 1.73 or x, because we also have the negative value, or x is equal to negative 1.73. These are the values where x, where g and h are equal, where g and h are equal. These are the values where these two graphs are equal. Another thing that they can ask for a domain. For a domain, so you can already tell that this function of what of g, this function of g is also, it has this vertical asymptote of which is y is equal to 1, but it also has this it has the horizontal asymptote of y is equal to 1, but also the y-axis where x is equal to, 0 here. It also has that asymptote. So if we were to write the domain for that function, the function of g, let me just say g at x domain is gonna be x is the element of okay, x. And guys, I hope you remember how we find the domain, because it's not always gonna be what you call this thing. It's not always gonna be 0. It's not always gonna be x is equal to 0. Maybe just a quick reminder, if we have that function of g, maybe let me write in red. If we have that function of g at x is equal to 3x plus 1, and we are looking for the vertical asymptote of this hyperbolic function, we equate this denominator to what? To 0. So we say x is equal to 0, and then here there's nothing to solve for, hence why the domain is what? Not the domain, but the vertical asymptote, VA. Hence why the VA is equal to 0. But you can have another case whereby maybe, let's say, we have a function called what? Called P at x is equal to 3. Okay, I don't have a space anymore. P at x is equal to 3 over x plus 1 plus 1, just for argument's sake. And then we're looking for the vertical asymptote. Then what we're gonna have is x plus 1 is equal to 0. We equate this to 0, and then our x will be essentially be negative 1. That means our vertical asymptote will be located here for the graph of p of x here, and not on the y-axis. So I just wanted to mention that point also, in case with the questions that we're gonna do today is not covered, just in case it's not covered, so just wanna mention as many things that can be assessed, So maybe just put a box here so that you can clearly see which is not part of this question. Okay, I was also doing the domain here. Maybe I should also do it in red, the domain. So our vertical asymptote is 0. So our graph doesn't exist where x is equal to 0. Our graph doesn't exist where x is equal to 0. So, but if we look at it, come here, look here, you can see that our graph is continuous in this direction. So it will start where we don't know. Very, 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 very fast. It's going to be a very small value of which we call negative. infinity. So x, if we were asked the domain of this function, x is the element of negative almost wrote 8, negative infinity. X is the element of negative infinity to positive infinity. Here, on this side it also goes to positive infinity, but x is not equal to 0, you know but x is not equal to 0, so our graphs goes from negative infinity up until will exist for the value, all the values in negative infinity up to negative infinity, and also all the will exist for all the values up until positive infinity, but our graph doesn't exist for the value of x whereby x is equal to 0. So that would be our domain. By this statement we have covered all the values of x where our graph exists. And then, okay, let's move forward. Write the equations of the asymptote of f. Okay, now we are asked the equations of the asymptotes. The equations of the asymptotes of f. If f at x is equal to minus g at x plus 5. Minus g at x plus 5. Okay. It's 6.3. It's 6.3. F at x is equal to minus g at x plus 5. Okay, so what we have to do here is to start first by substituting the equation of g at x and then add the 5, of which will be, then after that we'll calculate the equations of the asymptote. F at x is equal to negative, let's open our brackets, open brackets, the equation of g at x is 3x plus 1, if you remember, and then we add that 5. Therefore, f at x is equal to negative 3 at x minus 1 plus 5. F at x is equal to minus 3x and then minus 1 plus 5 will result in positive 4. Okay, so maybe we can start with the simple one. So right now, once we have this here, once we have this formula, you can see it's okay. Now it looks like something familiar, something that we are familiar with, of which is that equation of the hyperbola. The equation of the hyperbola here, y is equal to a over x plus q, and q is our horizontal asymptote, is our horizontal asymptote, ha. So just by rearranging this into that form that we are used to, we now already have the value of q here, so q, we can just say y, y is equal to 4, of which is a what? Is our HA, horizontal asymptote. And though they did actually ask for the thing that I was introducing here for the vertical asymptote, whereby I said do as we equate this denominator into what? Into 0. So for the vertical asymptote, we're gonna say x is equal to 0. Nothing to solve for. So these equations, they have the same what you call this thing, vertical asymptote, and of course it's 3 marks. So the 3 marks is just for substituting this g of x and solving Once you have this, until you have that form and solving, and then you are able to identify the horizontal asymptotes and then the vertical asymptote. That's your 3 marks. Okay, then let's move forward. Okay, maybe what we can do is just sketch this graph here. You know, I wish we had some space there to sketch. I wish we had some space there, you know, to sketch what you call this thing, to sketch it on this here, on those x's, so that you can see the shift, that this graph made. So they shifted it, they shifted the graph, what you call this thing, vertically. What are we gonna have? We have that horizontal asymptote, of which is what is a +4, +4. And then what do we also have? We have the vertical asymptote is x is equal to 0, so it's just this one. Our graph will not touch these two things, will not touch this line, and it will not touch this vertical asymptote, whereby y is equal to 4. This is our x. So our graph will not touch this and it will not touch that, So we're gonna have a graph like this. A graph. A graph. Wait, sometimes this pen. Maybe let me start with this one. Okay, there you go. Yes, our graph will look something like this. It will approach this line, but we're not gonna touch it. It will also approach this y-axis, but it's never gonna touch it. So it's just been shifted up. So that is our graph. Okay, then let's move on. Let me see what I can mention maybe about this graph also. It's gonna be -4, -4. I wanna see something quickly. It's gonna be 3 over 3. Okay, we can move on. Yeah, I think we have answered everything. Okay, let's find another question that we can do while we still have time. I think I've already screenshotted something. Add an image. This is the one we're doing. This is the, yeah, let's do this one. Wait, this one starts at question 6. Let me see. I want to see if it doesn't have question 5 like the other one. Let me come here. Maths. Okay, I see now. So we're doing this question 5. Wait, okay, we did this one yesterday, and then we finished the question 6 today. The one I'm looking at right now, sorry about that. The one I'm looking at right now, I think should be 2017. It should be 2017. Just wanna see. Trade 10 past papers for 2017. For 2017. Okay. So apparently I didn't screenshot the the one for question 5. And usually the functions, yes. The functions are on question 1 and 5. Let me just do it like this. It shows drafts of here x. Okay, it's a parabola, and f at x, it's a straight line. It's a straight line. R and S are the intercepts of G. R and S are intercepts of G, and then T is the intercepts it's the y intercept of G. Or those first two R and S are the x intercepts of G. Graph F passes through R and T. Graph F passes through R and T. It passes through R and T. Okay. Um, Maybe just to look at a few things here before we start answering this question. Uh, these graphs are equal here. Where the graphs catch each other, they are equal. So if we go down and find the equation whereby there, that's 3 marks. You can already say those two. You just equate these two graphs and then you solve for x, and then you get your answers. What else I should mention? Graph of y has a positive gradient. It has a positive gradient. The graph of y is gonna have, yes, a positive gradient. Our m will be positive. Will be positive. That's the graph of f, and then our graph of what you call this thing, the parabolic one, is facing down. So our a value will be negative. So these are the small things that should always be at the back of your head. You know, these things should be always at the back of your head. You can even use them to assess if you had a right answer or an incorrect answer. And I also highly encourage you guys that whenever you get into the exam and then you start answering the question, don't just go and start answering this question. Read the statement, make sure you understand the statement, and then just try to remind yourself of what you already know, before you go in and answer this draft. If you want to remind yourself of a range or a domain, start by reminding yourself of such things. And then if you want to remind yourself, it's okay, I'm dealing with the straight line function. Let me remind myself, if it's like this, then it means it has a positive gradient. Or if it were like this, it would mean it was going to have a negative gradient. Just remind yourself of what you already know. Just maybe identify your intercepts, your what you call this thing, identify your asymptotes, if it's an hyperbola, or if it's an exponential. Just start by identifying what you already know, and what you'll see happening is that thing will boost your confidence. That thing will boost your confidence. By the time you get into answering question, sometimes you'll find that maybe you've already answered some of the questions. You've already answered some of the question. Then it becomes easier. It becomes easier. But if you start answering the question right away without even reminding yourself of what you already know about the situation that is presented, then you can get the first question and it's something that you don't know, then your confidence is out of the window. You start even forgetting what you already know. Okay. I don't mean to preach, but let's get into it. 5.1, write down the range of G. G is the parabola, And remember, okay, we're looking for the range. I almost confuse it with the domain here, with the domain, with the domain here. Okay, we're looking for the range of G. So we're looking for those values where our function of G exists, and we can tell, okay, it's facing down. We start here, we have a turning point there at where y is equal to 8 here. We have that 8, and then our graph just starts there going down. So, and it goes continuously down up until negative infinity. So for the range of G, we will say y is the element of, starts with the smaller value, negative infinity towards to 8. To the positive 8. Once we reach that value of 8, our graph doesn't exist above that value. Our graph doesn't exist anymore here. It doesn't exist, only exist from that 8 up until negative infinity. So it's gonna be like this. That is our range. Okay, first mark. Number 2, 5.2. 5.2, write down the x coordinates of R. X coordinates of R. Okay, so what did they mention about the R? That it is the x, it is the, yes, it is the x-intercept of the graph of what you call this thing of G. So another thing, this graph is symmetrical about the y-axis, is symmetrical about the y-axis. So the x-intercepts, if they give you x like this, it's just gonna be what? It's just gonna be this. It's just gonna be 2 also, but in the in the negative, So r will be what? Will be -2 and 0. That is your x coordinate. So you can simply just say x is equal to -2. Okay, and then calculate the values of A and Q. So I think right now they want us to solve that formula. Okay, let's come here. Let's come here and say 5.3. We're looking for the values of A and Q. With Q, remember what we said it was? With Q for a parabola, is there. Let's get into it. Q is the y-intercept. Sometimes I said it also can be a turning point, of which is the case that we have there. But Q is the y-intercept. And what is the y-intercept? We've already been given is T and 8. So our Q our Q our Q is equal to 8. Q is equal to 8. Okay, let me do like this. Y intercept y intercept. Okay, that one is bad. Is our y-intercept that we have been given there is 8. And then let's move on. We'll try to move fast because I want us to also do question number 6 for this one, so that we can maybe do something different tomorrow or on Friday. Okay, y-intercept, we already have a q. We're looking forward now for a. Let's come here. G at x is equal to ax squared plus q. We already have q as 8, and then we're looking for a, so we can just take any coordinates here which lies in this graph. We can take 2 and 0, we can take 0 and 8 in order to calculate the what, our value of a, and substitute in grx and x. So let's pick 2 and 0. where to y is equal to 0, we are taking these coordinates in order to calculate the value of a. You know, x is equal to what? Is equal to 2 squared. X is equal to 2 squared plus q. Oh, let me substitute the value of q, of which is 8, and then we transpose 8 into the other direction. It's gonna be what? A 4, 2 squared is 4, into negative 8, and then we divide by 4. Therefore, a is equal to negative 2. A is equal to negative 2. Remember what I told you is that if this graph is facing down, the a is going to be what? It's going to be negative. So we are already at least somewhat correct. At least somewhat correct. And then, yeah, I don't know, maybe let's just take another coordinate just to show you guys that you can use any coordinate to calculate the value of a, that lies on that function. Let's also take 8 and 0. Maybe use a different color. 8 and 0. G at x is equal to ax squared plus 8. Our what's it called this thing? Our y is 8. Our a is not gonna work. Wait a minute. Okay, a into what you call this thing, or it's everything is just gonna be 0 here. So that coordinate will not work, because now we have to insert 0 plus 8, and then this will cancel out. So that coordinate will not work, because everything would be equal to 0, of which the formula will not be disproven. The formula will be still correct, because 0 is essentially equal to 0, so we end up gonna have 0 equals to 0. So a will not be solved in this case. A will not be solved in that case. But if we were to use that other coordinates of -2 and 0, where x is -2 and 0, it's gonna be okay. Maybe let's just do it. Take another coordinate, because I want to show you that you can pick any coordinate to solve this. Plus 8, and then we're using the coordinates of r, of which we said is what? We said is -2 and 0. Okay, where y is equal to 0, a into -2 squared plus 8. It's negative 8. A, remember, if we are squaring a negative value, what do we find? We find a positive value. Why? Because negative by times negative results in positive. So it's gonna be 4 here divided by 4. A is equal to -2 again. So there you have it. Okay, so we already have, yes, essentially we already have the equation of g. The equation of g at x is equal to -2x squared plus 8. That's the equation of g. Is so what are they asking for in 5.4? Copy. They're asking for determine the equation of f. So I just copied that. Let's paste it here. And then let's determine the equation of f 5.4. 5.4 is on the equation of f. F at x is equal to mx plus c. We already have two coordinates for that equation, of which for that line 0 and 8, and then for that r coordinate, of which is -2 and 0. And then the first thing first that we can do is to calculate the trident. Remember that once we have two coordinates, we can calculate the trident. So it's gonna be y2 minus y1 over x2 minus x1. But in this case, let's just say yt minus yr is equal to xt minus xr. So our trident is gonna be the y for t is equal to 8 minus 0 over the x for t is 0 minus the x for r. Remember to put the brackets because we have to account for this sign. So m is equal to 8 over 2. So this one will cancel. Negative times negative will be positive 2. So it's 8 over 2. Positive 8 over positive 2 will result in 4. Will result in 4, which is a positive trident. And it makes sense because if the straight line graph is in this direction, our trident is supposed to be positive. Yes, I've even mentioned that. So it's confirming what I've already mentioned. Okay. Okay, maybe just use this one. Okay. So we have the trident. We can take any coordinates there. Just take the t coordinate. 8 is equal. Okay. Bring back the formula for x plus c. What are we calculating now? Calculating the value of c, which is our y-intercept. 8. Oh, you can actually just take it from here because it's already given. Our graph cuts y there, at 8. You can just say c is equal to 8, but let's calculate it because it's already given there. It's supposed to be 8 4 times. Taking this coordinate, remember, x is 0 plus c. Then c ends up being 8, ends up being 8. We could have also used this coordinates here. Let's hope it doesn't disappoint like that other one, but it won't. F of x is 0, 0, 4 into negative 2 plus c. This is going to be what? Negative 8 here. 4 times minus 2 will result in negative 8, and then we transpose it into the other direction. It will change sign, leaving c being what? Being 8 again. Okay, there you have it, guys. And then, we're looking for the equation. So our equation will essentially be f at x is equal to 4x plus 8. That's the equation of f. What's next? Okay, to determine use the graphs to determine the values of f, where for which f at x is equal to g of x. Remember what I was just talking about on that other what we call this thing, on that other slide where the drafts are equal. So these are the values they're asking for. Use the drafts. Oh, and they say use the drafts event. So is that coordinates of r and the coordinates of what? Of 8. So graphically, 5.1.5.5.1 f at x is equal to g at x, whereby 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 r is minus 2 and 0, whereby x is equal to minus 2, x is equal to minus 2, and whereby x is equal to 0, x is equal to 0. So graphically, these are the answers that we're gonna have. These are the answers that we're gonna have graphically. Okay, and then let's move on. Okay, maybe for the argument's sake, let's also do it using the equations, just equating the equations. This is the equation for g of x, and then the equation for f at x is this one, just to see if we are getting the same answers. But we probably have to use the, we have to, what we call this thing, we probably have to factorize and solve for x. If we equate these two equations here, so we're gonna have minus 2x squared plus 8 is equal to 4x plus 8. 8 and 8 positive on both direction, they will cancel. That results in 0. End up having 2x squared is equal to 4x. Okay, 4x, and then so this 2 is essentially something like 2x times x. This is what will give us the exponent of x here, 4x. Then once we have something like this, we can divide by 2x on both sides, 2x on both sides, and then x will cancel x, negative will cancel negative here, x will end up being negative 2, of which is that negative 2 that we got there, that we got there. Yes, so these are the values where these two equations are equal, and then graphically we are also supposed to determine the values of x for which x times grx, x times, okay, that is 5.5.2 times grx is less than or equal to, is less than or equal to 0, less than or equal to 0. So for this one, you can use your calculator and simply plug in the values, but keeping just an important note of this, of those two values that we have there. But let's go through and do it. So it's gonna be x times grx, x times grx, of which is what? Minus 2x plus 8 less than 0. It's minus 2x cubed plus 8 less than 0. If you multiply throughout by that by that x. But if we just look at this graph and look for where, because you can, that you can simply divide with this x here, and you will be left with what? X is less than 0, if I'm not mistaken. It's not gonna change the direction. This thing is not gonna change the direction since we are dividing with a positive. I need to confirm that, since we are dividing, because if I remember very well, it changes the direction if we are dividing by a negative. If we're dividing by a negative, so we're essentially looking for values of g at x, where g at x of x, looking for the values of x where g at x is less than or equal to 0, is less than or equal to 0. So remember, I told you to keep an eye on this, so we can just go to the graph here, and look at this graph here, graph of g. You can see it's below 0 once we are above what? We are above 2, and it's below 0 once we are below minus 2. X, let me maybe write this here, x is equal to 2, and x is equal to minus 2 here. X is equal to minus 2 there. Okay, so that x here is just to throw you off. Just find a way to remove it and only be left with grx. It's gonna be the same thing. because they're saying it's less or equal to 0. It's just to throw you off. It's just to throw you off. But once you have removed it, you are now simply evaluating this. You are simply evaluating this. So you can see, this graph is less or equal to 0 when x is greater than or equal to 2. These values here, as you can see that this graph is expanding in this direction, is greater or equal to 2. It's from that 2 going into the going forward, this graph will be less than 0. It's below the 0 axis. That's what they're trying to say basically. So for x is greater or equal to 2, our graph of x will be below 0. And then the same thing here we'll have when x is now less or equal to -2, because if we are going in this direction, these values are actually less than this value of which is x is -2. We're gonna have -4 maybe, or maybe let me just say -3, -4. Going forward, -3 is less than -2. I hope you know that. So this is our answer. you know so, and you are just doing it graphically. So g at x will be less or equal to 0, or x times g at x times g at x will be less or equal to 0, where x is greater or equal to 2, or x is less or equal to -2. That's your answer. Right there. And then the graph h is obtained when g is reflected along the line y is equal to 0. So which line are they talking about when they're saying y is equal to 0? They're essentially saying your graph has been reflected about the x-axis, because this is where y is equal to 0. So it's reflected along this axis. So instead of looking like this, now it's gonna be something like this. So if it's reflected about this axis, something that you can already tell is, okay, your turning point, instead of being 8, it's gonna be now -8. It's gonna be -8. It has been reflected about this, where y is equal to 0, and y is equal to 0 here at the x-axis. So your graph has been reflected about the x-axis. So write down the equation of h in the form, we're looking for the equation of this graph in the form of h is equal to um p x squared. H is equal to px squared, and then plus k. So that is 5.6. Okay, 5.6 h at x is equal to px 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 squared plus px squared plus k plus k. And another thing that I forgot to mention here with this graph, because this graph are essentially going to be the same, but now instead of facing down, it's going to be facing up, of which means that a, of which is p here, is going to be what? It's going to be negative. So everything will change. Just a simple way to do this. Which graph is the graph of g, right? That's what's reflected. Where is our graph of g? G at x is equal to, let me just copy this and then copy, and then you're just gonna reflect it. Let's paste here. So the graph of h at x is equal to negative x, because now negative g at x. This has been reflected. So therefore, our graph of h at x is equal to negative into negative 2x squared plus 8. You know, h at x is equal to uh, positive 2x squared minus 8 if we multiply throughout with that negative. So this is what we are left with, and then the value of a is positive, of which it's concave. It's concave, and then the turning point, instead of being positive 8, is now what? It's negative 8. So this is the final answer for 5.6. 5.6 is already 8. I will just quickly go through the other question, guys. Please bear with me. I know some of you are already tired, but since I will just try to be quick, you know, I will just try to be quick with it. And we started a bit late, so I hope that you guys can have few minutes to spare one or two questions. Six. Hopefully, is this one 2017? Yes, is this one. Let me see. Okay, it shows everything. Yeah, it shows everything done. Okay, in properties, um, k is greater than 0, but k is not equal to 1. Okay, another thing just to quickly mention, remember we had this p at x is equal to k at x. Hopefully you can realize that this is a what? An exponential function. Exponential function. Function of which leaves us with cubing the asymptote. Asymptote. You know. So it's very important to know those general terms. Okay. So kx is greater than 0. K will never be equal to 1. Okay. Not equal to 1. X-intercept at 2 and 0. We are given a coordinate there. The horizontal asymptote is y. So we can already solve for k, and we can already solve for this equation, because we are already given the asymptote. So they say y is equal to 9. So our q is equal to minus 9, because here we are given the asymptote. And then 6.1.1, write down the range of p. The range of p. Okay, so since we know that this is a exponential graph, and they've already told us that somewhere somehow we have an asymptote, an exponential graph, it looks like something like this. So if we are being told, we could see the asymptote is 9, then in order for us to just determine the range, we'll know, we see, once our graph reaches minus 9, it doesn't exist anymore. Anything below that, it doesn't exist. So once we have the asymptotes, we can pretty much determine the range for this graph, of which will be, maybe let me leave that sketch there for your understanding. This is the exponential function. Our graph starts from minus 9 going into positive infinity. So our range is anything above negative 9. So our range, we can simply say y is greater than minus 9. So we will have we'll have all the y values above -9. Our graph will exist for all the y values above -9, So this is our range. Okay, and then let's go to 6.1.2, determine the equation of P. Okay, now we are asked for the equation of P. P at x is equal to K at x plus Q P at x. Okay, we were given a coordinates, remember? They told us about this 2 and 0 intercepts here. So it's going to be something like this, 2 and 0. So we can use that coordinate where y is equal to 0, k squared plus -9. So, okay, now I'm writing a q there, -9. Okay, let's transpose the -9 into +9. We will be left with k squared is equal to 9, and then we put a square root on both sides, leaving us with k equal to 3. And then for the equation of P, we're simply gonna have P at x is equal to 3x plus Q. 3x plus Q. Oh, sorry, plus 9. Plus 9. And then remember what they told us. They told us that k can never be equal to 1. Oh, k can never be equal to 1. Okay. K is greater than 0. Okay, and yes, k is greater than 0. 3 is greater than 0, by the way. So we are still within that those boundaries that they gave us, or those properties for this graph. So sketch the graph of P. Here show the intercepts with the axis and the asymptotes of 9. The asymptotes. Okay, so we already have the what? The x-intercept 2 and 0. So we just need to calculate the y-intercepts where x is equal to 0. So it's what? 6.1.3. Okay, hey, let me just copy this for time's sake. Paste. Here we are doing 6.1.3. Sketch the graph of P, clearly showing the intercepts. Where's our formula? P at x is equal to 3 exponent x plus wait a minute, it's a -9. -9, I'm making a mistake here. It's supposed to be -9. Yes, -9. Okay, we're looking for the y-intercepts now, where our graph calls the y. So y-intercepts x is equal to 0. So P at x is equal to 3 into 0 exponent 0 plus 9. Anything that's raised into 0 results being 1. So P at x is equal to 1 minus 9. That will be -8. That is our y-intercept. Okay, we have the intercepts, we have the asymptotes. Let's go ahead and sketch our graph. Let's go ahead and sketch our graph. Okay. Y and x here, and then somewhere down there we have a -9. Somewhere down here we have a -9. This will be -9, and then the y-intercept just above it we have a -8, of which is the y-intercept, -8 here. And then we have the x-intercept at what? We were given a 2. Somewhere here we have the x-intercept, of which is 2 and 0. Okay, so our graph will look something like this. Yes, okay. Now my intercepts has fallen out of the range, but yes, you get the point. That is the y and the x-intercept. Our graph will look something like this. So you've sketched your graph. Okay, so let's go and see if we can quickly answer those questions on 6.2. And if maybe you need clarification on these things, I know that I'm going fast now. If you need clarification, please send it on the group. I just want to answer everything so that maybe tomorrow we can start a new chapter. If you guys are still not comfortable with this topic, we can just do more questions up until you guys are comfortable with the functions, Okay. And of course, hopefully, before your exams or before anything, your test, we'll be able to have a revision of everything else we're going to cover in these sessions. Okay, so 6.2, excuse me, 6.2. The sketch below shows that the graph of f at x, it's a f at x, f at x. This is the graph that they're talking about. F at x is k over x plus w. You can already tell that this is a form of a function that we have covered, of which is an hyperbolic function. This is an hyperbolic function. Hyperbolic function, and then theorems, of which is this graph here, of which is a straight line. And this straight line, you must notice something, that it is essentially an axis of symmetry of this graph. Remember that thing I was telling you, that this is an axis of symmetry. So you can already tell us, okay, an axis of symmetry will pass where we have an asymptote. Just those things. Before we even get into question, take out those things. The axis of symmetry passes through what? Through the asymptote. We have that axis of symmetry there. And you can, even by looking at the graph here, you can see this. Look at this portion of the graph and this. You can see that they are similar, so they are reflected. Look at this portion of the graph here, this one. Okay, maybe a different color. Look at this portion here. It's reflected. So this is your axis of symmetry. That's your axis of symmetry. Okay. Maybe let's remove this for now. That's your axis of symmetry. Yeah, but yes. And then it passes through the asymptote. That's your asymptote there. Okay. Let's go ahead and look at the question. Write down the value of W, the value of the, okay. F at x, f at x, f at x is equal to k over x plus W. What is W representing here? We have already covered this. It represents an asymptote, an asymptote. They can call it a W or what, but this is an asymptote, because we are familiar with this thing. We are familiar with this is an hyperbolic function. This represents an asymptote, but you can just look at this graph and just identify it graphically from this, from specifically the hyperbolic function, But our knowledge of the axis of symmetry, we have that graph there, of which is what? G at x is equal to minus x minus 1. This is a what? A y-intercept. At the y-intercept, x is equal to what? Is equal to 0. So we simply substitute 0 here, minus 0, minus 1, leaving us with 1 being minus 1. What is the minus 1? It's the y-intercept, but it's also what? The asymptote. So w is equal to minus 1. Okay. The point minus 2, hopefully that was clear, guys. Hopefully that was clear, so, and how we attained that value of minus 1. The point minus 2 and 7 lies on f, on this okay, this is the point. Calculate the value of k. Okay, so now we've given the w minus 1, we've been given x and y, of which is the point that lies on the function. Then we can simply solve for k. Okay, let's come here. That's a 6.2.2. 6.2.2. f at x is equal to f at x is equal to k over x plus w we've already calculated it is minus 1. We are given a minus 2 and 7 coordinates. We have minus 2 and 7. We have w equaling to 1. Then we can just simply substitute. We're going to have 7 here is equal to k over x minus 2 plus, okay, minus 1. Okay. And then we transpose 1 into it's positive. Therefore, we're going to have 8 k over negative 2 is equal to 8. 8. Therefore, it's 2 times 8. K is equal to 16. K is equal to negative 16. K is equal to negative 16. Okay. K is equal to negative 16. Let's move on. K is equal to negative 16. So the function will be f at x minus 16 over x our w is minus 1. Okay, that is it. Calculate the coordinates of p and q. Another thing that I hope that you note earlier on is that this is where our graphs intersect. This is where our graphs cut each other. So those values are actually equal. So in order to calculate, okay, let me do this. These last two questions here, but I've already told you how to answer them. Please do them as a homework. Sometimes it's good for you guys to also get your own practice, homework. You can send them on the group, you can send them directly to me. This will be your homework. Write down the values for each x. Okay, yes. So this will essentially and I hope I gave you all of 6.2 as a homework part. Okay, it's fine. Please just do this as a homework. I don't know. You can screenshot it, but I will also send the notes. Yes, please do 6.2.3 and 6.2.4 as a homework. So this will mark the end of our session. And thank you guys for attending. I will see you on Friday. This video will be shared on YouTube and everything. Thank you so much, guys.